All right, we are live. Hope everybody, wherever they are, holding up well. Kind of a strange day in history, but we proceed with a core group here. I think we'll have Will join us in a moment as well. He does have some updates on some testing he's done on the chemistry side, and I have some procurement parts updates to update folks on. One of the things I did want to say is we got our fan did arrive from Bulgaria. It is built like a quite robust metal. It's exactly 150 or 6 inches in width, so it fits nicely, and it has a nice little sort of wire that comes out the bottom. Oops, we got somebody else joining right now. So that's the latest part. I just got an indicator from UPS that later today I should get the bag of Wollastonite, and I'm supposed to get the monoliths. It looks like on the 14th. And then there's some other parts that I wanted to talk to you about because our clay option, at least in the short term, is very challenging. Just getting that made or getting one here. I think it is an awesome option that we should consider, but in the interest of time, we basically need a hot tube. So my thinking there, if I could just quickly share an image, is not back to the drawing board exactly, but I looked back at the Duravent products, and we had been looking at the stovepipe for all of this time. There's another product called Chimney Pipe, which is a bit more robust, and it has this kind of a clicking piece. So what we looked at before about having the short piece to put the fan and the heater in, and then the longer piece to put the monoliths, and leaving enough headspace in each for air to pass through on the bottom and the top. And so I called these guys up. They do have them in supply. They do click together. We could wrap some kind of a sealant, brace around the outside. But I think this is probably the best option for us to go with right now. And in terms of the damper, we had the idea for putting caps on the clay, and I looked up and did order some 8-inch silicone caps that can actually fit onto the top and the bottom of this. And those are easy to get ordered for very cheap and very, very short in increments. You can order them down to the centimeter in terms of their diameter. So I figured we would probably go with that just until we can figure out a better clay option. But to get building, we could use that option. But curious what people think.
So the idea of that is we would just manually clamp them on during the vacuum cycle instead of trying to electrically.
Yeah, that's what we talked about last week, David, is finding a kind of a damper that really meets our needs is very expensive. So you have this jump from a $100 part to a $1,200 part. And then as we were talking through it, it's not the kind of thing that happens every 5 minutes. We can think of long-term solutions for how to automate the closure of that in some other way. But just for the short term, to have caps that we can put on there and clamp down almost like I don't know if you know that kind of there's ways of sort of clamping it so it'll stay on. So we don't continue to get bottlenecked with that. I think just going with a high heat silicone cap is probably the best thing so we can proceed with everything else.
That makes a lot of sense because it could be several months before before we've learned everything we can learn without it, before we'll be ready to automate the whole system.
Yep. Great. And Thomas and Charles and Will, I did have a good call on Sunday with Alex on the programming team, and we talked through kind of a general, what are the things that we're programming for? I told him about the damper situation, but then we started to think about, automating the vacuum, the heaters, the fans, and then also coming back with some kind of feedback system tied to the sensor, or when certain things are done to have a beep or an LED. So I don't know if you talked to Alex since we kind of scoped all that out, and he was going to continue to explore it. So so that is progress there.
That sounds fantastic.
Yeah. So these chimney pipe, I could get those. They could arrive in 48 hours. So if you guys are cool with it, I say let's order the goddamn chimney pipe, 7-inch interior diameter. We can drill holes into those the way we want to. They're double walled as well, like the stovepipe, which is good for insulation and heat. But if you guys are okay with it, I'm just going to go ahead and order it.
Yeah, that sounds great.
Okay. Cool. All right. So Tom and Charles, how was last Thursday? Any good sort of developments for on your team side?
Yeah, it was a weird day last week. I believe it was. Right, one second. I want to make sure I got my day straight. Yeah, it was on Halloween. Was our last meeting, and we're working with college students, so a lot of them were missing, which is understandable and things like that. So we didn't do the GitHub tutorial last meeting because we were like, we don't want to have to do it twice. Like that's kind of miserable. And so we had about like half the team there, and we thought we'll probably just do it next time. So we're gonna do it this Thursday. But we talked a bit more about what we talked about the previous week. Like just passing that along, talked about the plug, we talked about the alert system. I also talked with one of the programming members, Kaylin, has worked on a website before. And I know you really wanted to do that, Chris. So they talked about tying the alert system into that website as well. It's kind of a conversation thing we talked about. Talked a little, and yeah, that's the main points.
I brought that up, Thomas. Also, my son's soccer practices on Thursday are now over. So what I could do is come on Thursday and drop off the heater, drop off the the fan, hopefully the Wollastonite, if UPS is correct. And maybe if I order right now, I might even have that chimney pipe here by then. So I'll come by Thursday. One of the things me and Alex talked about on the programming side, we did talk about the website interface a little bit. And I was sort of looking at, could we add it as a page on the open air WordPress site? You know, could we possibly work within that? There's all sorts of stuff you can embed in there. If we don't want to do that, if there's some technical reason for having another website, but it's certainly cheap and doable to have it, you know, as its own page, maybe on open air site. But we can maybe on Thursday talk a little bit about with the programming people what they think would be optimal for this use case, and we'll go with whatever they think is best. I'm also ordering Alex a Arduino Mega, which he wanted as thought was the right one to do kind of triple duty in terms of the things that we're trying to program. David, I don't know if you have any thoughts on that at all. That was just in terms of, and I can't remember what kind of Arduino we used for the original one, but that was the one Alex had his eyes on. Oh, I think you're muted.
I used an Adafruit Feather it's got a much more powerful processor, but any kind of Arduino is probably fine. Just make sure you have enough pinouts, and the Mega should. It just doesn't run as fast, but there shouldn't be anything that depends on that. Usually the best advice is whichever one you're used to and you're familiar with, so you don't have a learning curve.
Yep.
I was going to say that we use the Arduinos on our last machine on the Carbon Farmer. So
good. Okay.
Go ahead and do that. Sounds good. I at the end am going to show one other part. I've been in touch with the sequestration team on Discord. Evelyn, is that her name, or Evie, or Erin? She's the one who sent me the bag of the link for the Wollastonite that I ordered. I have another thing, a part that I found that might serve our purposes for the mineralization thing that I'll show you and share with Erin as well. But before I do that, I know, Will, you have potentially some testing updates on your end with some of the sorbent stuff you've been doing. And did the sorbent arrive yet?
Oh, shoot. Let me go check on that. I did have one question, actually. Yeah. But the name that it came in on, was it under your name, Chris, or was it my name by chance?
I put your name in there.
Okay. I'll double check them, because the way it works here at UT, or at least in the building I'm in, is that if anything comes received and they receive anything downstairs in the mailing department and it has, like, let's say my name, they'll just email me. So I haven't gotten any emails yet. But it could be just because maybe it didn't come directly from my lab per se. But I don't think once they get it, they should notify me. I don't think they'll, like, return it for any reason or anything like that if it doesn't come directly from a UT source, I guess.
I'll email the Sigma people. It's Sigma Millipore is the supplier. That'll say that on the box. So I'll see. They haven't sent me any things like your bag is arriving or anything like that. So
Okay.
let me just find out. But my understanding was it was only supposed to take like 3 to 5 days, and I ordered it a couple weeks ago. So it might be on your side in receiving. So
Okay. Let me double check. Immediately after this, I'll go downstairs and check on that.
okay, cool. All right. So what'd you find out, Will?
Yeah, so I tried a new procedure. So I'm kind of excited to show this. I think it actually has some promise, and I think it'll work well for our monoliths. I'll go ahead and quickly just show the presentation. So this is something that I shared with the group on Thursday. It was a smaller group, so unfortunately not many people got to see it, but I also had a good turnout for students to come and actually work on it. So I offered kind of like a teaching experience type thing, which is like just come and watch, nothing like too intensive, just see how the PEI gets distributed into like the solution, and then sorry, I'm trying to.
There you go.
Okay. Let's see. Sorry. Can you guys see the presentation?
Yep.
Okay. So let me just back up just a little bit. So kind of to reiterate what happened before was that directly putting PEI onto a solid Illumina surface seemed to not be the most optimal way to do it. And I think what's really going on is that the PEI, which has a bunch of nitrogen groups, can't really find a good anchoring spot, or it can't chemically bond to the oxygen groups on Illumina. So it's having a hard time getting grafted on. At least that's what I've been finding with the little mini monoliths I had. Am I frozen, or are you guys able to see?
If you're changing slides now, we are not seeing it.
Yeah, if you're moving slides, we can. There you go.
Oh,
We just saw it.
there you
Yep.
Okay. Not sure what happened. Presentation is not working, I guess, or it's not showing through for some reason. But I'll just click through the slides like this if that's fine. So
Yeah, that's working.
okay. So what I told the team was that I think we have to clean the surfaces for sure. So whenever these monoliths get here, and Chris, you said they're going to be made of not walsonite but cordiorite.
Yeah, they're going to be made of cordiorite, which is fine. Yeah. Will, I can't remember. I think you were sick, but when I did a little bit of research on that, apparently cordiorite is good at constant heat cycling.
Oh, okay.
Like corundum and alumina are not as good apparently at that. If they have to heat them and cool them down frequently, so I think that's probably why cordiorite is the preferred material by Clarity and other.
I think there's more elasticity to it, whereas like alumina is more.
Crack.
Yeah.
Yeah. I forget. I forget what the term is. Brittle.
Yeah. Brittle.
I can see that actually. That makes sense because our alumina crucibles that we use here in the lab do crack over time, and it's just because of the heat cycling. So, granted, we do heat them to like 800 C, but I can understand that actually. So, that makes sense. But basically, what I've been figuring out is that we definitely need to clean the surfaces pretty well before we start doing anything with it, regardless of what procedure we use. So, what I told the group was that we have to do a KOH bath. So, it's basically just this bath of potassium hydroxide. And what the potassium hydroxide does when you dip your monoliths into the bath of KOH, it'll etch out a little bit of the surface. So if there's any like contaminants on the surface from the manufacturer, or if they put any like weird coating on it to try and protect it, the KOH should clean that off pretty well before we start doing any work.
Okay.
I tried that with the mini monoliths I had, but it didn't seem to make any difference with trying to just graft PEI directly onto it. So what I found out in the literature is that some people use this thing called a silica primer, and I think this is what I forget what the guy's name from Clarity Tech is. Was it
Hirsch?
Hirsch? Yep.
Yeah.
I think this is something that they use as well, right? They use a silica coating beforehand to adhere.
Yeah, that is what they use. Yeah.
But their method's a little bit different, right? Because they coat the silica first, then they kind of like calcine it, they dry it up, and then they put their sorbent on, right?
Yeah, that makes it like stickier. It's almost like the one side of a Velcro, I think. When they kind of bake the silica in, it makes it the surface exposure of the cordiorite better for doping with or adding the PI.
Is Kirsch ever going to come and talk to us again?
We can when we're ready to invite him. And what I was going to ask too is I'll just sort of time set this on the YouTube video, and I can, or maybe we can summarize before the call ends, like the key questions that you have. And I'll send him the video so he can look at a couple minutes of where we're at. And but I'd love to invite him to come. And I don't know if we want to do that. I think I said last time if we have where's my camera? If we have the monoliths in hand and talk to him once they arrive, or we could do it beforehand, whichever you prefer, Will.
Okay. I think I think let me try and do a little bit more experiments first to see if this coding method works. Basically what I'm gonna try and do is a little bit more multiple coatings and see if I can get more mass to increase for the monoliths I'm trying right now. If I'm stuck and I'm not seeing an increase in mass, then maybe we can contact him. But I think if it works, then I can try it out when we got the actual monoliths, and then maybe then it'd be better to talk to him because then I could show him some results from those and see if it's in line with what he thinks should be happening from their end at least.
Okay, great.
So basically what I was trying to do, so I'll get a little bit into the chemistry. It's not super complicated, but basically I'm trying to make a silica primer coat. So it's kind of the way I was explaining it to the team for the DAC guys here was that it's kind of like when you paint a car, you don't just paint directly onto like the metal or the plastic necessarily. You have to clean the surface and then put a primer coat, and then you paint on top of the primer. So it seems like it's going to be something similar for us here as well.
Do we have to like sand it down, Will? Is it that kind of thing or something?
I was
Like,
thinking about that. Yeah, I was thinking of doing like a physical abrasion cleaning, but I think the KOH bath should be enough because it's pretty. It literally breaks off pieces of the surface, so it should be okay. If this still doesn't work, we could try the physical abrasion too. That might be a good way of cleaning it as well. Maybe physical abrasion first, then the KOH bath. I think those two would be a pretty good combination. So maybe like sandpaper, like a fine grit sandpaper to try and get some surface off. I'll keep that in mind. So basically what the silica is, all it is just silicon dioxide, so SiO2. So silicon, when you look on the periodic table, it's in the group directly below carbon. So it acts very similar to carbon, where it can form 4 bonds in general. And when you have silicon dioxide, what it is you have these free oxygen groups, and then you have some OH groups hanging around as well. These oxygen groups are what's pretty much necessary to graft PEI onto the surface. The idea here is that the nitrogen groups on PEI should react with some of these oxygen groups and then either displace it or form a direct bond with the silicon, or maybe a bond through the oxygen. It's honestly not well known what is actually going on, but what I think is happening is either the oxygens are leaving and then the nitrogen group attaches onto here and it's right on silica, which is then on the surface, or it's bonding directly onto oxygen through a nitrogen group. Regardless, some covalent bond is happening for silica with PEI, and that's kind of the idea. This is what it looks like. Just silica. It's called silica gel in like lab settings. It's not really a gel per se. It's a fine dry powder, but they call it a gel. And I think the reason for that is because in organic chemistry, it's used for chromatography, which is just separations. So like purification, separating out 2 different products based on polarities. And silicon dioxide is very polar. So if you have a compound that's non-polar, it won't want to stick to this. But something that is polar will want to stick to it. So if you have a mixture of that, you'll be able to separate it off based off of how long it'll interact with silica versus not interacting. But we can disperse.
Do you have that, Will? Do you have that in the lab, obviously, since you've been playing around with it, right?
Oh yeah, I got like a whole bunch, and it's super cheap. So
Okay.
I have an excess of it right now. Yeah.
Okay, great.
And so there's also this thing called silica sol. So if you ever look into like buying silica gel or silica solutions, it's always called the silica sol. And I didn't really know what this was, to be honest, but the more I looked into it, pretty much all silica sol is a colloidal dispersion of silica in water. So a colloid is a fine nanoparticle that's not fully dissolved, but it's dispersed in a solution. So you can think of like milk, for example. Milk has like a bunch of like fats and like lactate groups in it, and they're not fully dissolved, but it's also not just like crash out the bottom and completely separated, right? In milk, it's a homogeneous mixture. Similar to similar to milk, silica can also do that, where it's not fully dissolved, but it's in a fine dispersion. Actually, I have here at my desk, it's maybe going to be hard to see, but this is dry silica powder, so hopefully people can see that. This is just a fine powder like that, free flowing. But then when you disperse it in water, it doesn't form like a clear solution, which if it did, that means it'd be fully dissolved, but it forms kind of like this cloudy solution. And that's the colloidal dispersion of it. And then basically silica sol is just a percentage of silica in the water. So you can have like 40% silica sol, or you can have like 50%, whatever, based on the volume that you use for the solvent, which is just water. So we can potentially make that or buy it. This is just the actual silica powder dissolved in water, which I think is just the same thing. But when you want to get like the actual ratio down for the percentage and be like very confident that this is 40% like silica in the solution, it turns out you have to like actually do a whole reaction to get that. So I didn't want to go through that step first because I don't know if it's fully necessary, but it might be for the procedure. But instead, what I just tried doing is just dissolving silica powder into water and then using that as like my homemade silica sol.
Awesome.
Um,
So Will, do you kind of dunk the monolith into that first and just have it like soak up in it, and then after the bath, and then cook it?
Yeah, pretty much. I actually did something. It's like a one pot solution. So you actually make a silica dispersion with the PEI in it, which is a little bit different from what I think Kirsch does, where they first do like a primer layer and then they put in the solution of PEI. So they kind of do it in one step. So what I'm trying to highlight in this slide here is that in the literature that I found, there's several procedures they had, but the one that matched ours the closest was this bottom one, the C one. And what they did here is that they took DI water, dissolved their PEI in there, and then took their silica sol, which is just silica dissolved in water as well, and made this like slurry of PEI and sol. And then they dipped their honeycomb monolith into there. I think it was overnight for 12 hours, and then they dried it in vacuum afterwards.
The
only
you have that, right? You have a vacuum heater, right?
Oh yeah, yep, we got
Okay,
that.
cool.
Yeah, vacuum chamber. They can heat up to 100 C and hold vacuum, so that's not an issue. The only difference in their procedure, though, is that they made their own silica sol. They made it by taking this tetraethyl orthosilicate and they hydrolyzed it. So they basically removed these little ethyl groups and they got silica out with a little bit of ethanol to form the colloidal dispersion. I don't know if we necessarily have to do that for ourselves. I think hopefully this works out, and preliminary results show that it is increasing in mass, so I think it is working. But doing multiple layers will give me the most confidence. So I pretty much tried the same thing. So I made the solution of silica gel and PEI in solution, and then we dipped our monoliths in there, and I have some of the results next. So this is just like the outline that I did for the DAC team. On Monday, I think I had about like 6 students come, and I have a whole bunch of pictures on my phone of just like some of the students like, you know, pulling out the PEI, getting to essentially play with it and see how sticky it is, and then
Send it, Will.
Okay. Yeah. You guys want to see it on Discord, or should I send it?
Pop on Discord. I might even just kind of tweet one out. Just you know, I like the little signals that we're showing that we're getting there. So
Okay. Totally.
Also, Will, please send that to us. I'll pass it along to net social media. Don't want that.
Okay, totally. I'll do it. I got a whole bunch
Thank
of pictures, so it looks cool. But yeah, so it's kind of like a good learning experience to just see like what it actually looks like to work in the lab. And PEI is kind of like hard to work with, I'm not gonna lie, but that's just kind of one of the things that comes with the chemistry, right? It's mainly because it's really sticky. But I personally think it's kind of fun. One of the ways they described it was that PEI looks like a molten Jolly Rancher when it's in the jar. That's like the consistency of it. So I thought that was kind of cool. And then when it's dissolved in the water, someone said it was like kind of like honey. So it went from like a molten Jolly Rancher to like honey, and that's kind of the consistency in the solution that we got. But here are the results. So this one on the left, what we see here is what the monoliths look like after they've been dunked into the solutions that we made. And one thing to note is that this one on the left, it has a kind of like chunks on it. And I think those were just like granules of silica that was left over. In practice, when we actually do make our monoliths, one thing that I foresee about the actual monolith itself is that it'll be like sticky to the touch. So we don't want to like bare hand this. We want to definitely wear gloves when we're working with it. But I think that's probably going to be how the monolith is going to like feel physically, is that it'll be sticky. It won't be like a smooth, like glossy finish or anything. So that may or may not be an issue in terms of like the inside of the chimney. Like it might, you know, stick to the walls or something. There might be like residual PEI stuck on the inside of the chimney. So that's one thing to look out for. But this is what it looked like after dunking them. So this left one is mini monolith 1, and this one's mini monolith 2. Mini monolith 1 weighs a little bit less than 2, so the one on the left is a little bit less. The one on the right's a little bit heavier. And then this picture is kind of like the flip opposite, where I kind of turned it over. So this is 1 on the right, and then this is 2 on the left. But basically, we dipped them into solutions, and the solution consistencies were, we made one that was 3 grams of PEI and 3 grams of silica, another one that was 6 grams of PEI and 6 grams of silica. And the one on the right, the heavier one, got the 6 grams, and the one on the left got the 3 grams. And so we dipped those in there, let it just sit there overnight, and then we took them out and dried them in the vacuum oven. And again, this thing happened where it's kind of like a little discoloration. So the colors, I think it looks like to me like it got a little bit darker. but the stickiness remained, which I think is a good indication that something's on there, which I'm pretty sure is the PEI. And when I did the weighing, I have kind of some like mixed results. This one that's on the right, which is mini monolith 1, which is a smaller mass one to start off with in terms of the weight of the monolith itself, that one increased by 21 milligrams, which is quite a bit more because before I was getting only like about 5 or 10 milligrams of increased mass. So this one increased the mass quite a bit. And I think there's probably 2 reasons for that. One is because there's like some granules, it looks like, of the silica gel left over, which may or may not be an issue. We may have to like clean it a little bit with like maybe blow air across it or something to get all the loose parts off and properly weigh it. But then also this solution that I made for the smaller one in the solution, it was more concentrated. The procedure calls for a little bit of water. They wanted like, I think 16 mLs of water for all the mass of PEI and silica, which makes a very concentrated solution. I know once we get the big monoliths, we definitely have to have a larger volume because we have to just have more volume to dunk and submerge the entire monolith. So we have to use more volume anyway of solution, of solvent, which is going to be water. So the second one, I made kind of like a less concentrated version because I used 50 mLs of water because that was kind of more in line with what I think we're going to end up using for some like initial trials for the monolith soaking. But I ended up making a much less concentrated solution. So this one on the left, which was the heavier monolith, that one ended up only increasing in mass 5 milligrams, which is way less. So it's about like 4, I think that's like 4 times less than the one on the right, which had a higher concentration of PEI based on the solvent that I used, the volume of the solvent. So I think overall, my conclusion for this preliminary results is that the more concentrated the solution is, the better, and that just kind of makes sense. So we have to optimize that once we get the real monoliths to try and find a balance between how much stock of like PEI and silica we want to incorporate into the solution before we dunk it in. And I think having the minimal amount of volume of solvent and like PEI and silica or PEI and silica gel that's needed is the best procedure, just to have it more concentrated. And also, I'm gonna try and do multiple dunkings. So I'm gonna take these 2 that have been dried and put them back into the solutions and see if I can get a higher increase. So basically trying to like stack the layers on top of each other. So that's the next step now. But yeah, it looks like it's gonna work. So pretty hopeful. Hopefully the next submersions that I make, I'm trying to do 3 in total and see how the masses increase. And if it increases linearly, then maybe we can find an optimization point where after maybe like a 3, 4, or 5 or something dunks, it doesn't increase anymore, and that's maybe like the saturation limit for that surface area that you can get for a given monolith. So that'd be some good information to know.
Surface area for getting the sorbent onto it, or for the actual CO2 absorption?
For the sorbent onto the monolith.
Okay.
Yeah. And it could be a case that maybe too many layers may not be good either, because maybe it's like too jam-packed, so maybe CO2 has a harder time like diffusing its way into the PEI mixture, so it doesn't ever make its way through. So we don't actually utilize all the nitrogen that's available from PEI to capture CO2. So it might be like an optimization where too many layers might be bad, but not enough layers is also bad. Hard to say right now. But my next steps right now is going to be to just do multiple submersions and see if that increases the mass any further. So, but it looks like it's promising and it is working. Just we have to concentrate the solution probably a bit more.
Will, in case I missed this because I'm a dummy, is there a way with those little Jolly Ranchers there to actually do a test of heating up and cooling down and measuring CO2 absorption of those little guys? Or
I don't think I'll be able to directly measure how much CO2 they can pick up, but I can definitely do like a cycling where I put them under vacuum and I crank up the vacuum to like, let's say 120, 150 C, and then cool it back down to room temp and see how much stuff came off essentially, which we could say would be partially PEI as well. So some of it like degrading or anything like that during the heat cycling. I could do something like that for sure. Yeah.
Okay. Any questions from anybody? All right. So Will, if you want to summarize, I'll share this video with Kirsch, but if you wanted to take a minute to kind of really specifically summarize the key questions that you currently have around that process and how you're doing it, that I can send to Kirsch, and he can look at that. And if he wants to look at the other part of the video, he can as well.
Okay. So let me just think real fast. If I had to bring this down to like 2 or three main questions. I would say the first one would be, how concentrated of solution do we need of a PEI, and what solvent it's in? Can it be water? Is it has to be methanol? That'd be my first question. So how concentrated the PEI solution? Um, Two would be the silica primer. Should we do it together with the PEI in one solution, or should we do a initial first step where we kind of bake on a layer of silica first and then do the PEI addition? Or can we do what I just tried here, where I kind of added both of them together and then just dunked them all in there in one pot, essentially? So yeah, so that'd be my second question, is like, do we have to make a primer coat initially, or can we do it all into one pot? I think those are main ones right now.
Okay, cool. All right, well, thanks, man. That's exciting. Can't wait to get some answers to those questions, but also to be able to, test it out with the actual monolith. So we'll have those in less than 2 weeks. So that's exciting. I did want to show one thing, and I'm going to share this with Aaron, and we can talk about it tomorrow night. But in looking at options for how we simply and inexpensively connect this to something where mineralization can occur, and I did look at a number of products. One I'm going to drop the link to in the comments right now, and I'll show you a picture of it. It's a product from Vervor. I think that's what the company's called. And it's this sort of, it looks like a kind of a chemistry set, but it's kind of an interesting thing. And it's made out of that kind of glass, begins with a B. What is it again? It's like super hot and heavy duty. And it has, what's that?
Borosilicate.
Yeah, that's it.
It's basically Pyrex.
Okay, cool.
The old Pyrex.
Yeah, it has a very high heat tolerance, and you can even apply a bit of a vacuum to it. So there could be a sort of a hack of this thing for mineralization that I was sort of looking at very simplistically. Is that you'd be able to pull the CO2 out of the vacuum, and it has this separatory funnel here, which has clamps on both sides, and it has some openings in it. And I thought that could be an interesting thing. As you can see here, it's got this like sort of pole in the middle that things can be clamped onto, where if you took this, oh, that picture didn't upload. Oh, no, yes, it did. If you looked at this little separatory piece there, that it has these sort of holes into it. I wonder with some care if we could possibly cut part of that off and insert the CO2 sensor in there and then seal it up and then connect it to that pole along with this. So the CO2 could first go into this little chamber here, which we've been looking for, to actually do a CO2 read of what's coming out of the DAC unit before it gets fed into flask 1 and flask 2. And the bottom flask is the thing that could have the wollastonite in solution, but it also comes with a heater that goes up to like 400 degrees. So we need heat to accelerate the reaction. And the top part, when I did a little bit of research, but I really want to find out with the sequestration team and make this a research project, is there's a couple of other things that you can add the CO2 first to make it better prepared for reaction with the wollastonite. And that's some kind of pH buffering agent, as well as like an inert gas like nitrogen. Whether we do that or not, I don't know. We could have it directly connect to the other thing, but that would then sit on a heater. So I was just looking at something that's relatively simple and cheap. It's like $150 that we might be able to sort of hack to do the mineralization, but that's just me ideating, and I want to share it with Erin and see what her team is already sort of thinking about there. But that to me looked like a potentially interesting option for testing.
I personally think this is a really cool setup, actually. I really like the glassware, and the thing you said, Chris, about like inserting the sensor into that.
Yeah.
We have a really good like chem glass guy, like a glass blower here in the chem department.
No way.
And if I bring it to him, he could literally like retrofit. If we have the sensor, I can give him the dimensions, and he could like, just convert the glass into like a holder. They could put the sensor in. So I think that could totally work. Like we could manipulate all this with him.
That's an awesome idea. And the other thing we could do is just in terms of how the vacuum fits, like we wanted to pull out of the machine, but There's another purpose. This little hole that you can see there, hopefully, on the top of the wollastonite beaker. There's a hole that's normally meant where you put a piece that's a temperature read in there, but it would be interesting to insert the other sensor, potentially there, have some other thing, so we could read what the CO2 concentration is in there. And if we've been able to affirm that there's no leaks, as that goes down, that means it's mineralizing.
That'd be awesome.
Yeah, you could even kind of connect that to the Arduino when it gets to a certain level that is equal to or close to whatever the ambient CO2 is. That means that it's been, or if it stops absorbing, that means there's been full absorption of the CO2 in the wollastonite. You could also connect another tube for vacuum there. Apparently, the reaction is increased if you apply a light vacuum to the actual solution. So again, it's pretty heavy duty glass, so we can make use of that other little spigot for either of those things. So, but let's see what Aaron and the sequestration team, they might have another great idea that they want to go with, but this to me looks like an economical, hackable way to potentially do it that has a pretty small footprint.
I don't know how, like in industry they would do these things, but I haven't really seen this kind of glassware being connected to other stuff. So I would definitely do it separately first, just to keep things somewhat simple. Like
Yeah.
you collect the CO2 and then move it over to the glassware setup manually.
Yeah, it'd be interesting to see how we do that. If we could even how we contain the CO2 in between, and we could even test out the wollastonite thing separately with a Airstream canister. Like we could inject CO2 into it from a soda maker, just to see how it works first, which I have in my house. So
you would definitely need something with a valve that where the CO2 comes in and then you don't release it from the valve until you're ready.
Yeah, until you get a read, you mean?
Just I don't know. I don't know what controls it, but just somehow you manually or electronically control the valve. Usually a gas tank or like a sense, just a valve that is controlled using an Arduino or some kind of computer.
What are they called? Solenoids, that type of thing that could open up and close automatically?
Yeah, it could maybe be that. Yeah, solenoid is just a mechanism. It's one of the types. I don't know. I'm actually not that familiar with lab like gas valves where you can control the output rate. I'm unsure what they're called, but they definitely exist because in my lab there's different there's gases that have to be fed through CO2, for example, that has to go into an incubator and then sensors control that.
It's like a regulator, do you mean? Like a flow meter or something?
Yeah. So most regulators, they're manual, but I think there are ones where you can control electronically also.
Okay, cool. Awesome. So anyway, excited to see you guys tomorrow in person. And then hopefully I would love it if the wollastonite, or not tomorrow, but on Thursday. No, it is tomorrow. Today's Wednesday. But again, I think even by this call next week, we'll have a lot of the main parts, including the chimney pipe, which only takes 2 days to arrive. So, we can start to really kind of get our hands on things and sort of think it through a little bit. But as I get those things, I'm going to kind of just bring them over to you guys in batches, so that you can, kind of get your hands on it. One last thing I wanted to mention, which is a bit kind of future looking, that has to do with the carbon removal challenge. So I'm involved in the organization of that, and we're planning on launching. Matt might have even launched on Monday, but we're looking for a May time period in New York in which that'll be held. It may be part of Carbon Unbound, or it might be done separately. But one idea I had with this, certainly I'm, thrilled, assuming that you guys are going to enter that. But regardless of what happens with that, I had an idea of adding programmatically like a DAC hack. So if we build this thing and the parts are relatively simple to put together, it would be kind of cool in New York to have like a day at a local makerspace or at NYU to maybe get a group of people together, including some of the other winners of the competition, to just build another one of these, but with some augmentation that we want to do. You know what I mean? And maybe invite other hackers that live in makers that live in New York and sort of record parts of it and stuff like that. So because I'm involved in the project, you know, I could just decide to do that and have it be part of the program. But I wanted to kind of put that forward for you guys. I thought that could be an interesting way to, you know, evolve this in a kind of an interesting thing that's part of the CRC. So just wanted to put that in your heads. If you guys are up for it, I can get you tickets to New York. So anyway, just wanted to kind of offer that for right after the end of the semester to, you know, head over.
Yeah, no, that'd be exciting. I'd be super up for it as long as I matched up with like my finals and things like that here, obviously.
Yeah.
I'd be super up for that. Yeah.
Okay, cool. Well,
more and also about us entering the CRC challenge, how is that going to work since it is just Epiphyte? Like, I don't know if that makes it. It's so different from like what a normal CRC submission would be.
Well, I would say that what this is kind of the equivalent of is like all of those teams generally had some sort of faculty involvement, right? So, you know, I've talked to Matt about it and he's excited to have Epiphyte, you know, be part of it. So, you know, I'm not worried. My involvement here, I'm obviously more of a cheerleader than anything and buying stuff. So it's not like my brilliant ideas are, you know, and I think once we start to build it, there's going to be a lot of sort of happy surprises. Hopefully we'll probably, you know, so, and we'll leave that to you guys. So I wouldn't sweat that too much. In fact, I promise you don't need to sweat it. So,
right.
All right, cool. All right. Well, that's all I got. Anybody else have anything to share or any ideas or? All right. Will, thanks again for putting in so much time and, you know, pushing the ball forward in terms of the chemistry testing. That was impressive and encouraging. So hopefully that gets us in the right
Good job, everybody.
Yep, definitely. All right, guys, keep on keeping on. All right.
All right.
See you later. Bye.
Thank you.
See ya.